bow, chicka bow wow. That's what my baby says. Oh, it's on. Okay. Anyway, I found this lovely circles review document that another teacher had. She was willing to share. So I thought I would just use this for my video. Then I also have what one of you asked for. I have a blank version, so I can load that up too. So I'll ink all over this for my video, and then I've got an answer key, and I've got blank ones you can try at home. And you've got 4 full days with the 3-day weekend. Okay. So here we go. We have circle D, and we know that GI is congruent to HI, so I might as well mark that right now. GI is congruent to HI. And the measure of angle, this is an angle symbol, DNK. Where is that? DNK. What? DNK is 90. Well, that sort of implies something, doesn't it? If DNK is 90, that kind of means that this thing has to be a tangent. Okay, great. Tangent with a T. Oh, come on. I'm using PDF inking now. This is a little different. Okay, anyway, so that's supposed to be tangent. Tangent. Oh, come on. I can't write on that? You know what I mean. All right, this could be a problem. I may have to change back to the other software. All right. I'm just going to try to sneak it in. Okay, now it's a T. All right, so it's a diameter. This is all just about labeling stuff, really, about identification in this first part. And yes, that is going to be an element of the test. Diameter, my favorite diameter is EM. I don't know if there's any other ones on there. Doesn't look like it. Chord, and remember, part of this is you gotta name it with the right type of thing. Like diameter would have to be a segment. A tangent would have to be a line, I believe. A chord would have to be a segment. That kind of stuff. Chord. Oh, there's a bunch of them on here. How about something weird like HL? I don't think anyone else would have picked that one. I see a couple other ones though, GH and GJ. A right angle other than DNK. Well, if that's a right angle, and if this is actually a bisector, then I think we have to have right angles here also. Right angle other than DNK, we could say, oh no, it happened again, GIF. I think that'll work if I do that. Okay, great. All right, tangent, well, I just named that. KN, and really I think for KN you could say, I said line before, line is always safe. It's debatable whether or not people let you say segment KN is a tangent, but I think it is. Anyway, line's always safest. Radius, there's a bunch. How about DF? Radius would have to be a segment, of course. Okay, inscribed polygon. Inscribed means it's inside the circle. The only one I see here, I mean, DIG this, whatever that is inside the circle, but not only one of the corners touches. The only one I can see here really is G to J to L to H. That's pretty much it. If there's another one there that I don't see, I apologize, but that's the only one I see, and that works. We only need one. Secant. A secant is a line that contains more than just a chord. Let's say line JL. There's another one there. I think GH would also work. I can name it by points on the circle, fine, but I mean the whole line J. Whoa, that was cool. The whole line J. I was trying to fix my letter there, but it didn't really do anything. Okay, it's JL. Minor arc. Arcs have to have a little curvy thing on top. How about GE? That's an extremely minor arc. It's just that big right there. But you could even say, GM is actually a minor arc. Major arcs, you have to list 3 points because they have to go around more than half. I know that E to M is diameter, so anything bigger than EM, like EML, would be major. And you still got to put the little arcy thing on top. Okay, great. Moving on. I can leave some of that up there if you want to see it. Actually, it's not very interesting to look at. We'll go ahead and get up here. All right, number 2. I'm just supposed to find F, and all I know is that this one's 100 and all these are the same. Well, if all these are the same, and I like how this picture makes it look like it's a little bit off. Like, to me, this one looks a little bit longer than this one, but I can tell that because this little banana-shaped piece is way fatter than this banana-shaped piece. But it says they're the same, so I have to believe it. So I have to believe that all these are 100. All these are 100 because all the segments inside them, all their chords are congruent. The whole circle is 360. Don't forget that. That means this little part right here has to be 60. And if that is 60, then the angle at the center is the same. It's also 60. Don't go thinking it's 30. It is 60 right here. This is the same as this. It starts to get half if I pull this across the circle, like something like this. In fact, let's go ahead and label that because I need it for B right now. 40 is half of 80. It's half of that arc across. So let's label this as 80 so we have it. And I'm also supposed to find A. Well, A, guess what, intercepts the same arc, and it's across the circle too. Just because it's closer over here doesn't mean it's any different than 40. So any different than that other angle 40. So it's also 40. Sorry if you can't read that. That's also 40. Okay, C. Well, this implies that we're talking about the center of the circle. And if this is actually a diameter, finding out that writing full words is kind of tricky on this thing. If that's really a full diameter, then you know this has to be a right angle. That's, I think, I was saying in class today, that's the second most popular thing people are going to forget. Big thing not to forget, number 2. Angle D then, or sorry, arc D, well, this is a diameter here, then this whole thing is 180. This is half the circle. 180 minus 65, I guess I could be doing this so you can see later where this came from. 180 minus 65 is 115. Do I have that right? I think so. I think I can leave these as is, and I can keep going a little bit. And yeah, I can answer the next few questions without losing those. Okay, E. Well, this is thing to forget number 1, I was saying. People are probably going to forget this more than anything. That if you've got a quadrilateral with all the corners on the circle, then opposite corners are supplementary. Not much to do there. G. This is really the same rule as what if it were like this, 40. The same rule as this, it's just pulled all the way. Like 40 was the same. If I move it over here to A, if I kept moving it so it was actually on here and I had a segment going across here and a tangent, it would still be half. So this 80 remains half of the arc that it's inside. So this arc here is still 160. Now, if you notice what I'm talking about here with major arc G is just the rest of the circle other than that. So here at G we have 200. H, this is that rule where this is not half of the arc because this is not the center of the circle. This is that situation where this one is the same as this one, and these are each supposed to be the average of the two arcs they intercept. So the 100 and the H are supposed to average out to 70. 100 plus H have an average of 70. So that means H better be 40 if you do the algebra on that. You may pause if you want to look at this some more and figure out where that came from. By the way, if you need to come in and ask me questions, or it'd be really cool, you could email me and you could put a little time on the video and say, Mr. Greg, I don't get what you did there at 7 minutes and 42 seconds. Okay. Next 6 problems. Alright, J. J's over here. It is kind of like the one we just did up here at the bow tie thing. The bow tie was that angle in there is add these two and divide by 2. Now when we get to J, it's, and I'll leave it so you can see that, it's kind of nice. It's going to be subtract these 2 and divide by 2. That's the rule in this one, and this is the sort of straight ahead way to get that problem. I got all the ingredients I need just to do that to find J. 100 divided by 60 over 2 is 40 over 2, which is 20. I feel like I'm zipping through these, but it's just so darn fun. Okay, and same situation here, just because one of them happens to be a tangent, it doesn't matter. It's the same as this rule. I take 160 minus K and divide by 2, and I should end up with a 30. That's something I have to solve, so 160 minus K is supposed to be, if I multiply both sides by 2, that's supposed to be 60. So if 160 minus something is supposed to be 60, the something better be 100. Okay. M and P, same thing. I've got these 2 arcs inside a outside angle. These all kind of look like bird beaks in a certain way, don't you think? Slightly different bird species, but they all have this sort of bird idea that there's a beak outside the angle. Why do I come up with these things after the review day? All right, I did the same thing in FST recently. So it's the same thing. P minus M. Whoops, M, I said. Ooh, can I undo in this? I can. All right. P minus M. Oh, but then that happens. That's fine. I was about to use another rule anyway. P minus M divided by 2 is supposed to be 70. I also know that P plus M is supposed to be 360. You could do this probably to check at the end. I don't know if you remember this, but we had this really nice rule that comes up enough, and they don't remind you of it enough that if those are tangents, this is going to happen. And notice in this quadrilateral here, which happens to be a kite, because those are, because those are congruent, and of course those would be congruent because they're radii of the circle. In this quadrilateral, I have 360 degrees. Those are both 90. This is 70. Whatever's here has to add up to 180 with the 70, so this has to be 110. Oh, please. That has to be 110. Oh, really? Okay. So, and if this is 110, that's the same as this arc here. So M actually has to be 110. That's always going to happen. If you have the ice cream cone sort of looking beak, that the angle, the intercepted arc here, closest to the beak, the face one, not the back of the head one, but the face one has to be supplementary to the beak. And I already know this now, that P minus M divided by 2 is 70. Or, I mean, think about it. This 110 plus P has to be 360. So this is 250 for that. Great. I really don't care to complete this, but I could. The other half of this, the other part of the system here is P plus M equals 360. Substitute one of those in, call one of them 360 minus the other one, and then substitute in here, do some algebra magic, you'll get it with this. But this 7110 business here with the two tangents and the supplementary thing saves everybody lots of time. Okay, is there a number here? This BD one down here. Alright, BD, all I know is this is 12 and this is 1. So the radius of this circle is 13. How on earth am I supposed to find this? Sorry, let me pause. Silly Mr. Craig. If this is 12 and this is 1, that means the radius, I just said this, the radius of the circle is 13. So guess what? The radius of the circle is 13. And if this is, I think we're supposed to believe this is perpendicular. This problem is impossible if they don't tell you that that's true, so I think I'm just going to go ahead and assume it. So now we have a right triangle, and I know the hypotenuse, and I know one of the legs. I can use Pythagorean theorem really quickly and figure out that that's 12. If I did x squared plus, this one comes up a lot, the 5, 12, 13, plus 12 squared equals 13 squared. If the pen would follow me, please, you would find out that x would have to be 5. Okay, so I think they left out their little right angle business, but it has to be there. Otherwise, it's impossible. D to B, this is looking very Pythagorean-y. Don't forget, O to the circle is 7. O to the circle has to be 7. That's got to be another radius. So I know this entire side now is 25. I have a right triangle. So I can figure out in this right triangle down here, 25 and 7, I believe this has to be 24 if I know my Pythagorean triples well enough. 7 squared plus what squared equals 25 squared. If you figure that out, you're going to get 24. It's great when you know these things. Life is so much easier. But yeah, you could do that on a calculator. You'd figure out that it's 24. If this one, B to here, is 24, guess what? B to D is also going to be 24. It's the original ice cream cone property. That if you have it, I kind of marked up all over that one, so I'll do it again. If you have this kind of bird beak, the one where they're both tangents, these have to be, those two things have to be congruent. And now it's not going to let me draw on there. It's like it's those two things, if I start way out, it lets me do it. Those two segments have to be congruent if these are both tangent. Okay. OD down in here now. We have another tangent. We have a 75-degree angle. O to B is supposed to be 25. I'm going to find O to D. Well, O to D is the radius of the circle. It's like saying, I'm going to call this X. What's nice about radius of the circle is it repeats there. If O to B, it's supposed to be a segment, I'm sure, not an array. If O to B is supposed to be 25, I mean, this is starting to look a lot like this now, isn't it? We got 25. This, whatever's left here, is 25 minus X. Now I could use a little bit of trig. I've only got 1 minute left. I don't know if I'll fit this on the video. You know what? I'm going to pause right here, and I'll upload the video, and then I'll put this in part 2. Okay. See you then.